with just identifying these certain things on the graph. So what do roots stand for? Or what are roots? Zeros, what's another word for it? Solutions, what do they mean though, all of them? X-intercept. So what are your x-intercepts here? Good, 6 and -2. So I would write them 6, 0, -2, 0. So remember XO, XO, zeros are your x-intercepts. So where would our y-intercepts be?
0.
Good, right here. It's where it crosses the y-axis, which is 0, 12. So right here is your y-intercept. Axis of symmetry. Where's that? What is it? I heard it. What did you say? 2, right? Because it's where it's this line. What is 2 though? What equals 2?
8.
Good. X equals 2. Axis of symmetry is x equals 2. On your test, it may try to trick you and say y equals 2. But remember, axis of symmetry is your x coordinate. What's your vertex? Beautiful. 2, 16. So right at the very tippy top, that point is 2, 16. Beautiful. Next one. Leading coefficient. Is that a positive Patricia or negative Nancy? Negative Nancy, right? So we know since it's concaving down, it's negative. Next one is domain. What's always a domain? If it's going
infinity and positive infinity.
Yes, Karan. Negative infinity to positive infinity. So those are always our domains for quadratics. What about our range? Looking at it. Let's look back at it. So remember, that's bottom up. So if we're looking at the bottom forever and ever and ever, and it's going down, what would I start with? Negative what? Negative infinity. And then what's the highest y value? 16. You guys see that? So range is just bottom up. So my range would be negative infinity to 16. And since it touches 16, it's going to be a bracket like that. So it's bottom up. The last two are the ones we really struggled with. The first one's increasing. So remember, when we're reading it left to right, I'm reading it left to right like this. When is it going up? Right here, is it going up? Yep, it's going up all the way until your x is what? 2, right? So when it's increasing, I'm going to just put it right here just so I don't have to scroll down. It's increasing from negative infinity. It's going up, 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 up until it reaches 2. That's when it's increasing. It's decreasing from 2 to infinity because it's going down. So increasing is just looking at when it's going up, and when it's going down is decreasing. The last one's positive, and when it mentions positive, it's talking about the y values. Is this y value positive? Is this positive? No. Is this positive? Is this positive? Yes, so from here, all these y's right here are positive, right? What x values are they positive at? What's this x value right here? -2 and 6. Notice those are the two that I used right there, right? So it would be positive between -2 and 6. So between those two x values is where the y's are positive. And increasing, we just said, was negative infinity to 2. Those are intervals. The last one, if you have room, or else write it above the graph, I forgot about it, is end behavior. So the last one is end behavior. So write this down. And so the two things when we look at end behavior as x approaches infinity, what happens with f of x? And as x approaches negative infinity, what happens to f of x? And so when we look at it, we go, okay, as x gets larger, what's always happening with the y's? So what's happening with the y's here? As these x's get larger, what's happening with these y's? Are they going up or down? Down. What about when the x's go towards negative infinity? What's happening with the y's? They're also going down, right? So in quadratics, the end behavior is always going to be the same, whichever it is. So since they're both going down, right here I would just write they're both going towards negative infinity. If they were both going up, they would both be going towards positive infinity. So it's a little bit different than exponential end behavior, because you kind of have to look at it. This one, you're just looking at the arrows. Are they going up or down? Does that make sense? Okay, so you guys are going to try the next one on your own. We're going to go over it. Just make sure you add end behavior. I forgot about that at the bottom of this one. I'll give you a few minutes to try the next one. You're doing the exact same thing. So you don't have to you can rewrite it, but you're finding the same thing. The roots, the y-intercepts, vertex, axis of symmetry. So you're going back up, and you can use the one next to it as a guideline. And so you're finding all those same things using this graph right here. Allison, what's the roots? Or the zeros? 3. Beautiful. Who got that? Give me a thumbs up. 3, 0, negative 1, 0. Perfect. Yasmin, what's the y-intercept? How do I write that as a point? Good. 0, negative 30. Ron, what's the axis of symmetry? What equals 1?
8.
Good. X equals 1. Who got that? Good. Because your axis of symmetry is this line. Kamari, what's the vertex? 1, negative 4. Beautiful. Keandra, is the leading coefficient positive or negative? Positive. Beautiful. It's facing up. Yasmin, what's the domain? Negative infinity to positive. Beautiful. Kanya, what's the range? Good. So when we look at this right here, negative 4 is the smallest, so it goes first. So negative 4 would have a bracket, so it touches it, and then it goes up towards infinity. So make sure you don't switch those. Remember, it's bottom up. Increasing. Angel, did you get this one? When we look at it. Good. So since it's increasing, it's going to be 1 to infinity, right? Because it's the smallest and biggest. So the x coordinate, so if you start at 1, it starts going up, 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 so till infinity. You could also just write it like this when x is greater than 1. They're the same thing. So if you wrote it like that, when x is bigger than 1, it's the same thing. What about when it's positive? Looking right here. What would happen here, Keandra? When did it try? When would this function be positive? So it's going to be like when x is greater than something and when x is less than something. It's going to look like that. So when is it greater than? What number is it greater than when the y's start getting positive? Looking at this. At 3, right? At 3, it starts going up to positive numbers. So when x is greater than 3, it's positive. I'm just writing an answer right here. And when x is smaller than what number? -1. Does that make sense why it looks like that? Because it's two intervals. If I were to ask when it's negative, between which two numbers is it negative? -1 to 3, right? So from here to here, all those y's are negative. Does that make sense, that interval? And the last one's end behavior. So as x approaches infinity, what's happening with the y's? Are they going up or down? Up. So right here, what would I fill in? Infinity, and then right here? Perfect. Does anyone have any questions about that front part? Looking at graphs and determining what's going on. That's like most of your logic tests. Cool. Next one, you're going to turn it over, and there's going to be two equations that look like this. This one I did on purpose, where you're going to have to use the quadratic formula. So we're going to be going over that, how to use the quadratic formula. And so I gave you all the blue little formula sheet, because I want you to make sure you know where is the quadratic formula on the sheet. You get this during the test. Where is the quadratic formula on that sheet? Under quadratic formula at the very bottom, right? So first I would type this into my table. So when you type it into table, it ends up being a decimal. So you won't be able to find it. So I'm going to have to use the quadratic formula. God bless you. First, is everything on one side of the equation? No. How do I get 3x to the other side? I add it, right? When I add it, does it go first, middle, or last? Middle, right? So now my new equation, I'm going to just write it right here, is 2x squared plus 3x minus 20 equals 0. I can't combine it with anything because nothing has the same last name. So first I need to get it into standard form. You also can see right above the quadratic formula on that formula sheet it says standard form, so you can see the way it's written. Then to find the roots, you use the quadratic formula. Remember, you need to know what it looks like, so on your paper, I would first write the quadratic formula. But before, let's label our A, B, and C. What's our A here? 2. Just 2. Victor, what's our B?
3.
Just the number though, just 3. And then Kamari, what's our C? Beautiful, -20. Now I'm going to cross this out so you don't have to look at it. You're just looking at that top part. Then we write our quadratic formula in. So it's x equals -b. And so you can see it right on your formula sheet. Now you can either simplify it a little bit to make it easier, or type it in your calculator. Now when you type it in, you've got to make sure you remember the parentheses. So I'm going to rewrite this, but instead of the letters, I'm going to put parentheses. Like that. So I rewrote that same formula, but instead of the letters, I put parentheses. Then all you have to do, you can either simplify it or you can just type it in your calculator like this. So you can start off with using the plus. So in your calculator, you can use plus first and then we can go to minus. So first, when you're typing it in, what's all the b's? What is b equal? 3. So I'm going to put, instead of b, I'm going to put 3. Instead of a, I'm going to put what number? 2. And instead of c, -20. Don't forget that negative. Now, you can either type it in like that or simplify. Does everyone know how to put this into your calculator? What do you press? What's the button we press to get a fraction? N over D. So you press N over D. And then you're typing that just like that into your calculator. So negative parentheses 3 plus, we're using plus first, the radical. And it should just look exactly like this. Make sure this is a minus sign because some people put negative and it's wrong. So put that right, practice putting that right into your calculator. If you're someone who likes to reduce it, which I probably would, you can do this first, figure out what that number is, and then that way you just put it in that radical. So like if I'm going to reduce it, I can go like this. Oh, the opposite of 3 is negative 3 plus, what's 3 squared? 9. And then I see 2 negatives, so I know it's going to turn to a plus sign. What's 20 times 2? Times 4. Yes. All over 4. So that way you're typing less into your calculator. What is 160 plus 9? 169. And that way you can just put that into your calculator. It might be a little bit easier than if you're typing that whole thing. So you can always simplify that beforehand. Did anyone get the answer with the positive? Did anyone get it yet? I would make sure you're practicing putting this in your calculator because when the test comes next period, I'm not going to be able to like help you out with that. So you got to answer all the questions now. Anyone get it? You guys? What is it? Yep, negative 2.5. Just negative 3 plus. And then the second. And then you put everything in there. Minus 4, 7, 16, 2, and 2, and 4 over 2. Sorry, it's positive, right? 2.5? Yeah. 2.5 comma 0. So you should have gotten 5 over 2 in your calculator, and you got to turn that to a decimal. Then, to get the other version, either you highlight it in your calculator, what you just typed in, click enter, and then change that plus to a minus sign. Make sure you're changing the correct plus sign. Don't change like that sign right there. You're changing this sign to a minus. So this one now changed to a minus sign. What do you end up getting when you do that? I would make sure to practice and ask questions now so you know you know how to do it. What do you guys end up getting? Anyone get it yet? Negative 4. Yep. So the answer for that one was negative 4 comma 0. So that means those are your two x-intercepts. You don't need to use the quadratic formula if it shows up into your table. So if you were to type that equation into table, negative 4 would show up. But 2.5 wouldn't because it's a decimal. So like you could even check by putting that into table, negative 4 would show up in the table, negative 4 comma 0. Does that make sense how we did that one? So this one is going to be in your table. I want you to type the other equation into your table and find it. Oh. Yes, sir. That's your first one. Then your second one is going to change this right there. That's what she said. anyone find it after putting it into table? So now this one you're putting into table, the second equation. Did you find your roots? What are they, guys? Good. -3, 0, and -5, 0. Does anyone have any questions on how we find those roots? We put them into tables and we look at, hey, when does our y's become 0? At -3, we can see it was 0, and at -5, we can see it was 0. That one you can do through a table. Next one is vertex. This vertex is going to be a decimal, so it won't show up in your calculator. What equation do we use to find the vertex? It's part of our quadratic equation. What part of it gives us our vertex? The -b, it's the outside of this. You guys see that? The outside of this quadratic formula is what gives us our vertex. So we use that. See, it's on your blue paper, your quadratic formula. You need to know that the outside of that quadratic formula is your vertex formula. We still use the same numbers right here. So -b over 2a. What is -b? So we have negative, what's your b? 3 over 2, and what's your a? 2. When you do that, you end up getting -3 over 4, which is -0.75. That is your x-coordinate of your vertex. If that's your x-coordinate of your vertex, what is it considered? That's your x-coordinate of your vertex. What is that also considered? Axis of symmetry, right? So when x equals -0.75, that is your axis of symmetry. To get your y-coordinate, you have to rewrite the original equation and plug in your x value. So here's my original equation. But instead of x, I know my x is -0.75. So I'm going to write that in like this. That's just the original equation from above. When you do that, you type that right into your calculator just like this. Don't do any math beforehand. And get your y-coordinate. What does your answer end up being? Anyone get it? Yeah, I got -21.125. Let me see. Yeah, so this will end up being -21.125. Does everyone get how to put that? You just put that right into your calculator. You forgot the negative. For -0.75. What's the domain of this? What's the domain of this function? -infinity to +infinity. What's the range? First of all, is this going to be a looking at the leading coefficient right here? Is this going to be positive or negative? Positive, right? So we know it's going to go from a certain number to infinity. What is the y-coordinate of our vertex? What is the y-coordinate of our vertex? Looking right here. Which one's the y-coordinate? Good, because that is our minimum. So our range would be from that -21.125, and then it goes up forever and ever. So what would be right here? Infinity. Cross this out. What's your y-intercept? What's your y-intercept on that graph? It's 0, what? You might have said it, but I don't. That's your y-coordinate of your vertex. looking at the equation, how could I tell here's the original equation? Which one is the y-intercept? Which number here is our y-intercept? We got her, yes. Negative 20 is your constant. You could always type that into table and find it also. Cool. Last part before we do like a practice quizzes real quick is up here. Here is our vertex form. Do you guys see where it says vertex form on your blue paper? Right above quadratic formula. Do you guys see that? It has the formula. So it looks like this. Y equals A x minus h squared plus k. And so it's telling you, hey, the opposite of that number is your x coordinate of your vertex. What could you also do with that equation if you totally forgot about that? What could you do on your calculator? Put it into table, right, and find the bump where it's sandwiched. But I could also look at it and be like, hey, I know the x coordinate is the opposite of h. So what's the opposite of 4? Negative 4, right? And then I know it's the same as k, because it says plus k. So it's the same as that, so it would be negative 1. That's my vertex. You could even put it into your table if you forget that, or just to make sure, and see that when you put it into table, that negative 4, negative 1 is the one sandwich. What number is your axis of symmetry? Good, so it's x equals negative 4. It's your x coordinate of your vertex. What's your domain? Good. And then we know that this is a positive, Patricia, because there's an invisible 1. And what's the minimum value? Here's my y. It goes down to negative 1 and then goes up forever. So knowing that, I would know it goes from negative 1 and then goes up forever to infinity. You also need to know transformations. So if I'm looking at this, even if I'm looking at this point, right? 0, 0 is the main point. Here's my new point, negative 4, negative 1. That's my new point. What did I do to get from here to here? Where did I move? Did I move left, right? Which one? Left. How many left did you move? 4. So I moved left 4. Also looking at the equation, I can go, oh yeah, plus 4 means left 4. Yep. So I go left 4 and then down 1. Yeah. And then last one, what's the y-intercept? Look, put it in your calculator.
Okay, thanks.
Put that one in your calculator. What's the y-intercept? Good job. So how do I write this? 0? Yes. So that one you just put into your calculator. Where your x is 0, that's your y. Cool. If you know that, you're going to be fine. You also need to know multiplying polynomials. Does anyone want to go over that? Okay. So write this down. I'll give you a few minutes to try it out. You also need to know, like, so it looks like this. I'm going to extend the page. So 2x to the third, 4x squared minus 5x plus 1, and then x plus 4, x minus 6. So those are two different products. So you're simplifying, you're multiplying them together. So see if you can try to remember how to do that one, or both of them, and then we'll go over it in just a minute. I'm actually going to change all these. I'm going to change this to 2x minus 6. But I do with the coefficients? What do I do with the numbers, the big ones? Like 2 and 4, what would I do with those two? Multiply, so what's 2 times 4? 8. Then if there's variables with the same exponents, what do I do with the exponents? Add them. So what is 3 plus 2? 5, right? So it would be x to the 5th. Then I just do the same thing again. So what's 2 times negative 5? Negative 10. And then what's this invisible exponent right there? 1, right? So what would this be? X to the what? X to the 4th, right? Because 1 plus 3 is 4. Then I do the last one. 1 times 2 is 2. And then there's nothing to combine it with, so I just bring down the x to the 3rd. And that's my answer. I can't combine any of them because none of them have the same last name. They have to have the exact same exponent. You guys good with that? All right, last one. You can use box method, distributive property, FOIL, however you want to do it. I'm going to do the box method. So the x plus 4, I'm going to bring right here, x plus 4, and then 2x minus 6. Don't forget to put the sign with the number that goes next to it. What's 2x times x? 2x squared. Good. 4 times 2x, 8x, so positive 8x. Negative 6 times x. And then negative 6 times 4, negative 24. So even if you did it the other way, you'd still be getting the same answer. Then I write down all my terms that are in the box. 2x squared plus 8x minus 6x minus 24. Then which two can I combine? 8x and 6x. What is 8 minus 6? 8. Positive 8 and plus negative 6. What do you end up getting? What's 8 minus 6? 2. And I bring the x with it. And then I just bring the other ones down. 2x squared, there's nothing to combine with, minus 24. That's my answer. Does that make sense? Yes, no, maybe? Okay. Are there any other questions you guys have? Do you want to do this? Okay. So, Ms. Thompson's going to do a quick quizzes with you. As soon as you get in next period, you are taking your test. So I would make sure